Okay, so this is the last day of instruction for math intermediate algebra, math 012. The lecture today may be a little bit long. We were supposed to cover one problem on Monday, but I've decided just to tag it on to the end. So if we do go over and you would like to leave, again, it'll be recorded. So you can go back and watch it. I'll upload it after we're done. So what we're covering today is section 9.1 and 9.4. We're done with logarithms. So everything we've talked about logarithms, that is the last bit that we're going to cover on them, was yesterday and last week. Are there any questions before we get going? Okay, move that down there. Okay, we'll see if any of that gets in the way. I've got all these side things open. Okay. I have these announcements. Now, you don't have to write all these announcements down. I'm going to send out a announcement. So it's the same thing. I'm just going to send it out. I just didn't send it out prior to class because I want to see if I need to add anything, right? If there's any questions you guys have or think that should be added to it. Okay, so to go through the announcements, the daily work for exam 5 can still be turned in if incomplete. Oh, I see. Yeah. So if you haven't got it done, you should be able to still submit any of the Alex or Blackboard daily work from exam 5. So, but if you have any trouble opening up any of the Alex stuff, let me know. But I think I allowed late submission all the way up till the last day of class. But that's just for exam 5 stuff. Just focus on that for now. So again, if any of that daily work you want to complete, you can do that. Again, the exam 5 will be available starting Tuesday, May 5th at 8 a.m. That's Tuesday until Wednesday, May 6th at 8 p.m. So any adjustments there seem okay? Okay, so that is when exam 5 will be. That leaves us to what's going to happen Monday, May 4th, Star Wars Day. Well, review on Monday, May 4th for class it will be. So there's I'm not going to do a Yoda impression, but I wrote it like Yoda would say it. So that's fun. I'm a huge fan of Star Wars. So big day. We'll have a review that day. Also, they're uploading all of the last Star Wars movie up to Disney Plus. So if you have that, you can watch the entire saga or all 9 movies. I don't know if that's what the saga is. Okay, so that's May 4th. We'll have a review on Monday. So again, we'll show up regular class time. You can ask me questions if you have them. The review for exam 5 will be sent out tomorrow evening, so I'm finishing that up. So I'll send it out tomorrow evening. You'll see it either on Alex or by email. And by email it'll be a PDF, but that'll be available up till the start of exam 5. So that's what that's saying, till tomorrow evening, or uh, well, hold on. Tomorrow evening and May 1st. Oh yeah, until Tuesday at 8 a.m. Right. So at the beginning of the exam is when that Alex review is no longer accessible because that's when the exam starts. So that is what that's talking about. The review's not due, but it'll mirror. Oh, question. This is Brian. Okay. Again, Brian, if you missed it, I'm going to send out an email of all these announcements right after class. So it's the same thing. I typed it up so I could just send it out as an email. So again, you don't have to take a picture or write it down. Okay, so the review is not due, but it'll mirror the exam. So if you want to know exactly what's on the exam, the numbers will be different, of course, but just refer back to that exam review. Okay, that brings up the final exam. The final exam, again, will be available May 8th. From midnight May 8th until Monday May 11th at 11:59. So you'll have a couple days to do that. I would, if you can, you can push it back and do a little bit of studying and preparing for it. I did get a final exam review from another instructor who's taught this class a couple times. I plan on sending that out as an email, PDF with the answer key Wednesday at midnight. So, yeah. I mean, I won't be up, but I'll have it sent as an announcement. I mean, is that okay? I think that would be fair. I want you to focus on exam 5, you know, get a good grade in there for exam 5 before the final exam starts. It's not too bad. I mean, the final exam review doesn't have much material from exam 5 on it, just because we're covering that right now. Um, but it's good. And the answer key that he wrote is very, very well written. So again, the exam is 32 questions. You'll have 1 hour to complete that. Or you'll have 3 hours to complete that, but it must be done in one sitting. Not on sitting, but one sitting. You can definitely stand and take it, but it must be done in one sitting. So you can't close the exam and start back up. Any questions? Okay, move down a little bit further. So scratch work for the exam is highly suggested. Again, no partial credit will be given without it. So if you were to miss a problem, Brian, I did mute you. So if you want to talk or type in the chat, you might have to unmute yourself. Scratch work is suggested. No partial credit is given without it. That means if you just leave off a negative on Alex, it'll mark you completely wrong for the question, and without scratch work, I won't give any partial credit for that. This is a good way for me just to see, your work and everything like that. Again, scratch work must be completed or submitted to Blackboard no later than 30 minutes after the exam is completed. So again, you finish with the exam at 9 p.m. at night. It has to be submitted by 9:30, and check the timestamps and stuff like that. Email me if you have any other questions. Again, oh, there's still more. Yeah, let me know if you have any questions on that in particular or anything else. Working on exam 5, or no, excuse me, working on grades. I haven't really graded anything or entered anything yet. I've got a couple things with my classes I'm taking that I'm trying to finish up. But I'm gonna work on that, and it should be all done and returned to you by Monday. I was gonna try it by tomorrow night, but we'll wait and see. I don't want to promise anything, but definitely by Monday you'll have everything back. That includes exam corrections if you've submitted them. So if you do want to submit any corrections for exam 3 or 4, that can still be submitted on Blackboard. So yeah, you can get that submitted if you'd like to. Okay, that's all the announcements. Again, I will send this very announcement. I'll have to change that one correction, or I'll just forget about it, tonight at 8:30. So you'll get an email with that. Are there any questions over that material? Okay, so we'll go ahead and begin with section 9.1. We're talking about the distance formula and the midpoint formula, as well as circles. So that is our main study. We're going to do a little bit on 9.4. 9.4 is kind of a review. It just looks a little bit different from stuff we've worked with. Okay, so 9.1 section, or the first part of this, is the distance formula. So there's a lot going on in this picture. The one thing wow, it's a bad line. The one thing that you should look at, right, is the question here is, what is the distance between these 2 points? Oh gosh, that's why there's a picture, right? We want to know what the distance is between these points, right? And I'm just constructing this so you can kind of see where this came from. I was trying to find a picture without all the garbage on it, but I could not. Wouldn't call it garbage, I'm about to use it. So to find the distance, basically what we're going to do is we're going to ask, well, how far is x1 from here? So you can think of dropping this line down here, this perpendicular line, right, perpendicular to this axis, right? So then, well, if we were to do the same thing here, we could draw a perpendicular line. And notice that this point right here is x2. So, or excuse me, right? So what it's saying is the distance between these 2 points is x2 minus x1. Again, you could have x1 minus x2, but we were just consistent here with x2 minus x1, right? Right. So that is what that's saying. I'm going to stop drawing on that picture because I think you can kind of see what's going on, right? So we've got this distance that we're wondering about, which is given by a, right? So x2 to x1, that's our distance. We're going to use this idea to find d. Right? I'm going to move it on just a little bit further, right? Because the question here is what in the heck is d going to be, right? That's the distance between x1 x2, like these 2 points, right? We want to know what that is. And in a similar manner, you can figure out what the distance between here is, right? And the distance between that is given by the absolute value of y2 minus y1. But be thinking, right? This forms a right triangle. So I have a side A and a side B. How is this related to side B? Anyone want to help me out? What math formula does everybody know? I shouldn't say everybody, but most people know from high school geometry or trigonometry. That has to do with right triangles, A, B, and D, or as you might have heard it, A, B, and C. Anyone know the name of the formula? Okay. Well, hopefully you're seeing, well, we know that A squared plus B squared is equal to D squared in this case, right? This right triangle, we have our two sides, right? The square of those is going to equal the square of the hypotenuse. Well, now what if we plug in our values for A and B? Well, A is, oh goodness, A is x squared minus x1, the absolute value of that squared. And B is y2 minus y1, that quantity squared, the absolute value, equals D squared. Well, notice now that these are just absolute values, right? You're taking the absolute value and squaring it. So it's, is it called the standard form? The Pythagorean theorem. So what this right here is, I just joked because I heard, I think it was probably a meme on Facebook that said like, people know the Pythagorean theorem, a squared plus b squared is equal to c squared, and that the mitochondria is the powerhouse of the cell, right? Those seem like two things that just stick, at least they stick in my brain. And I think whoever made the meme, it also stuck in their brain. Right? This is the Pythagorean theorem. Right, because we got a right triangle. Okay, so this is kind of redundant. We've got a square of the absolute value. What we can look at is just x squared minus x1, the quantity of that squared, right? So replacing it, oops, with the absolute value, or is replacing it with parentheses from the absolute value, right? Because the absolute value already makes things positive, so we're squaring it so we can replace it. So finally, to solve for D, oh, we're getting there, right? We can square root both sides, right? We want D by itself. So to undo a square, we square root both sides. And what we end up with here is square root plus or minus x squared minus x1. I'm just showing you where the distance formula comes from. I think it's kind of neat. And that's equal to D. Now the question is, can you have a negative distance? I think. No, right? You can't have a negative distance. So we throw out this negative, right? Because distance can't be negative. Right? So distance is not negative. So what we end up with here is the distance formula. And that is given right here. So the distance formula is, again, we just kind of derived it with that reasoning there using the Pythagorean theorem, that we get x squared minus x1, that quantity squared, plus y2 minus y1 quantity squared. And that's given, you got these 2 points, right? Remember, these are ordered pairs, right? Ordered pairs are of x and y, right? Ordered pair. So let's use the distance formula and see what we get. Okay, so we want to find the distance between these 2 points. I think it's always good to write your x and y above them, you know, calling back that it's an ordered pair. Now it doesn't matter which one is x1 and which one is x2 as long as you're consistent when you fill it in. So let's go ahead and get this written. Oh, it's hard to write square roots on this digital pad here. All right, so I'm going to have this one go first. So we'll have -2, and we're subtracting it from the next one, looking at the distance, and we square that, right? So in this case, this would be x2, x1, this is going to be y2 and y1. Again, doesn't matter. So you're adding now the distance between 3 minus 1 quantity squared. Oh, wait a second. Now remember, you're subtracting in the equation, so you're subtracting a -1 quantity squared, right? That's just coming from the formula. Okay, so let's evaluate this and see what we get. So I gotta work on writing my square roots. So in the inside here, you're subtracting -2 minus 4, so hopefully see that's a -6, that squared. Here, 3 minus a -1, so a double negative is a positive, so we have 3 plus 1, or 4 quantity squared. Okay, continuing on here, we still got a square root. This is -6 squared is 36. 4 squared is 16. And what is 36 plus 16? We find that that is going to be, what is that? It would be, did I add everything? Okay, I did. 52, thank you. 52. Okay, so then we want to simplify this radical down a little bit further, right? So we want to see, is there any sort of way we can simplify the square root? So to work on 52, let's go up here, right? So let's break apart 52 into our prime factorization. Does 52, well, that must be divisible by 2, because there's a 2, right? It ends in a 2. What is that going to be? Is it 13? Did I do that right? No, I did not, right? Because that'd be 6, right? So that's obviously not correct. Would it be 16? That doesn't sound correct either. I'm not using a calculator today. We're winging it. 4.
22.
Oh, is it 22? 26?
36. Yeah.
Okay. Yeah, that sounds 12, 6. Okay, cool. Thank you. 26. Okay. Again, we can break it apart, right? So 2, I know this one. This is 13. So we've got 2 times 2 times 13. Okay, so what this tells us is that 2 squared times 13 gives you 52. Okay, so that means we can simplify this down a little bit further, and we can have it as 2 squared or 4. So I'll just write 2 squared times 13, right? So the square root of 4 is 2. So this actually reduces to 2 square root 13. And that is your simplified answer and your distance. So it doesn't come out to a super nice distance, right? It's irrational, but that is what we found, the distance between these 2 points. Are there any questions on this example? So you'll be asked to find the distance between 2 points, and that leads us to our first daily work problem that we're going to see, but the second one that you're given. I wasn't paying attention in the first daily work problem. We're going to deal with the midpoint later on. So that is why we skipped to daily work number 2. Okay, right, so we want to know, right, what is the distance here? We want to know what is that distance. It's not 2, that's a question mark. Okay, so we're given these 2 points, -4, 2, and 3, -2. Again, it's always a good idea have it as x and y, so you know, keep track of your variables, your ordered pair. Okay, so recall your distance formula. So that's probably a good thing to have handy when you take taking a test is to know what the distance formula is. So again, I always choose the first one to make it x2. I mean, again, you could have the other one as x2, just make sure you're consistent. So this is x2, oh my goodness, this must be x1. So -4 minus 3, that squared. And then again, this must be y2. So I have 2 minus a -2. Again, the formula already has a subtraction in there, right? So if you've got a negative, you're now subtracting a negative or a positive. It would become a positive. Okay, so working the inside here. This right here, when you're subtracting a -3, it's going to be a -7. right? So you're at a -4, you're subtracting 3, it's going to get real negative. Here, you're adding a 2, the opposite of subtraction, so it becomes 4. Okay, so what we're looking at here is whatever the square of 7 plus square of 4 is. So we're looking at 49 plus 16. Okay, what is 49 plus 16? Would it be 65? Did I do that right? Any input from the audience? Double check. Okay, thank you. Okay, 56. Again, we need to simplify, right? Is there a way that we can simplify 65 down? So again, looking at, can I move this? Is it just the entire thing? This entire thing. Okay. Um, right, so I'm looking at 65. Well, the numbers that you should be thinking about of how to break it apart isn't 2, right? Because it's not an even number, but 5, because it ends in a 5. So what do we get when we divide 65 by 5? 1, 5, 1, 15. What is this? 3, 13. So we get 5 and 13. So that means that both these numbers are prime. So there's no way to break apart 65 to simplify it any further. So what we wind up finding is that this is just square root of 65. There's no way to break it down any further. Make sure that I added everything correctly. 3, -2. So -4 minus that is -7. And then you've got 2 minus a negative, yeah. So 49 and 16 is 65. Okay, perfect. Yeah, okay, just making sure I did everything correctly there. Okay, so any questions on the second daily work problem? I'm gonna get a calculator out just to double check. Okay, moving on. The next thing we want to talk about is a circle. Okay, so let's kind of define some parts here on the circle. So HK, in this case, is called the center of the circle. So the point HK is the center of the circle. And then R is called the radius. So R is the radius. And so basically a circle is created. It is all of the points that are the radius away from the center, right? So it's the equidistant from the center. Right? So as long as you have your center, it is just however many radius it is away from that, right? So if it's 2, then it's just distance of 2. Every single x and y point that is 2 away from that. I was going to write that out, but I hope that explanation makes sense of what this is here. And so, okay, so basically, if you wanted to find the equation of the radius of your circle, what we're saying is that again, it is the equidistant, right, from the center. So it's saying that if you had an x, if you wanted to look at all of your x values, you want to find the distance from all of those x and y values that are equidistant from the radius. Which is why your equation of your circle would look something like this, because we're saying all of your x and y values that are the same distance, right, or the radius from that. Which is why your equation of your circle is given by this right here. So not just kind of talking through it, this is your equation for a circle. Any questions? Okay, the book also you know, has it written out of it being, you know, all the points equidistant from the center, and that is just what that is saying, which gives you your equation of a circle. Okay, so the standard equation of a circle, I should say the standard version, or the standard equation of a circle. Standard equation for a circle. Okay, yeah, so again, your center is point HK with radius R, and it's given by this. It's given by this equation here, where R is greater than 0. Again, you can't have negative distance. Here you've got, if a circle is centered at the origin, then H and K are 0, because again, remember that H and K are the center, which gives you just x squared plus y squared equals r squared, right? With x and y just differing with those. Okay, so there's your equation of a circle, kind of where that comes from. Let's graph. Let's graph one. So again, it's already written in the standard form. So this is your standard form, standard equation, I should say, of a circle. Now the center is going to be HK, right? And the standard equation of a circle, they're both written with minus signs, right? So just recalling here, right? Notice how we've got a minus h and a minus k. So that means to have this in this standard form, you want a minus sign on both. So in this case, because it's a minus, right, you can think of it that way, right? That we've got a minus for, and I guess, let me write it like this. Right, 36, you're looking at the square of that. So really it's 6 squared, right? This is the standard form of a circle. Okay, but another way to think about it than rewriting like that is it's just going to be the opposite of whatever you see in the inside, right? So your center is going to be 3, right? It's the opposite of -3, and -4 because it's the opposite of +4. So whatever is in the inside here, inside of your parentheses, it's the opposite of that constant. So +3 and -4. Okay, so once we found that, we go over here and we plot our point 3, -4. I apologize if the graphics are a little bit blurry. I tried to blow them up to make them easier to read. Okay, so 3, -4. Let me go down just a little bit. Right, so 3, -4 is about right there. And our radius is 6. Again, you could find that by taking 3, setting that equal. So 36 is equal to r squared. That means r is equal to plus or minus 6 whenever you square root both sides. But again, you can't have a negative distance, which is why you just have a +6 for your r. Okay, so a good way to draw a circle is count 6 spaces from your center in 4 directions, in the 4 cardinal directions. So I'm going to go north 4, so 1, or north 6, so 1, 2, 3, 4, 5, 6 right there, and 6 this direction, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 there, and then 6, 1, 2, 3, 4, 5. Oops, one more. Wait, right? 1, 2, 3, 4, right there. And then just try to connect them with the best arch you can. Wow, that is awful. But as long as you have these 4 points, it's clear that you're just drawing it from the radius. As you can see, mine is near perfect. So yeah, I challenge you to try that. Also, if you're using this, you can just, wow, somehow try to, yeah, there we go. I drew that. Okay, I'm going to delete that. Okay, so that is how you can draw a circle, given that you have the equation written in this form, right? The near standard form of the circle. Are there any questions on this problem in particular? Okay, well, let's look at the next daily work problem, question 3. And we want to, again, sketch the graph of this, right? We want to graph the circle. So again, right, if you wanted to rewrite this in the standard form, right, you're gonna have it written as a negative, right? So rewriting +3 as a -3, or all right. Rewriting it so this is a minus sign, then this would be a -3, right? So subtracting a negative as a positive gives you this form here. And again, we already have a minus sign, which is what we want. Again, to find what the radius is, you're going to take this number here, so 25, and you're going to set that equal to r squared, because that is the equation, the standard form of the circle, standard equation of the circle. So then this right here, r must be 5, right? So this is actually 5 squared. Okay, so here we are. We have that the center is, and again, be thinking that it's the opposite of whatever's inside of here, right? So it's a -3, and the opposite of a -2, which is a +2. That is your center of the circle. So we can go over here and plot -3 up to a +2 to about right there. And now you count equidistant, and I say the 4 cardinal directions, north, south, east, and west from this center here, and you're counting 5 because that's the radius. So, yeah. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't know if you count whenever you're moving game pieces if you're playing a board game. I find it really hard to. My first game night I went to with all my friends, I was like, oh gosh, they're going to judge me because I count. But most people do. Okay, and then you draw the best circle you can. I'm going to cheat, and I'm going to use this. And yeah, I should have paused it. I should have paused the video and then unpaused it so anyone watching it online was like, wow, like, how did he draw that? It looks perfect. So here's the equation of a circle using the center and the radius to find it. Any questions on the third daily work problem? Okay, moving on. We want, this wasn't a daily work problem, but just in case you see something like this, find the radius and center of a circle. We're not going to graph it. We worked on graphing up above. But I at least want to look at this right here. So to find the center and the radius, remember that your equation for a circle is given by this, right? With h and k being your center. So notice here that there's nothing written for, there's nothing being subtracted from the x squared or from x, quantity squared, right? So really, if you wanted to think of it this way, it's 0, right? You're subtracting 0 from x. Nothing changes here. This looks just like it does in the standard form, right? How do I do that? Here again, we need to figure out like what this would look like. Well, they're perfect squares, which is good. So you could always set this equal to r squared, subtracting or taking the square root of r on both sides and getting rid of the negative value because you can't have a negative distance. We get 5/3. So this is now 5/3 quantity squared, right? So just matching it with the standard equation of a circle, we can get this. Okay, so let's answer the question now. So the center is 0 and 10/3, right? Remember that it's the opposite of what you see on the inside. Not that 0 is a positive or minus, but here we've got a -10/3, so we're actually looking at a +10/3. And then the radius is 5/3. Are there any questions on how I achieved both of those? Oops. Okay, so let's move on. We want to be able to write an equation of a circle, and that is the next thing we're going to deal with. If you're still writing that down, I'll move it up just a little bit. Okay, so based on just some information, can we get the equation of a circle, right? So we're going to look at this example in particular, which is your fourth daily work problem. So remember or recall that the equation of a circle is given by just what we wrote up there. So x minus h squared plus y minus k quantity squared is equal to r squared. Again, with h and k being the center, right? So that's just recalling the definition. Right here we have some important information given to us. And in particular, it's we're given the center, right? The center is 3, -2, and we just have that it passes through some point, right? So we can think of it as, let me write it like so, right? We've got this center here. I'm just going to sketch it. So what is it? 3, -2. So -2. Now we don't know how far, we don't know what the radius is, right? So we're not too sure, but we do know that the circle passes through 1, 5. So we're here at 1 and we go up to, hold on, I lost count. 1, 2, 3, 4, 5, 1, 5, right? So it's not a clear shot up from there, right? So we just can't count up there. But we know that the circle goes through here, right? It looks something like that, but we don't know what the radius is. Radius is a mystery. So what do? Well, let's plug in the center, and then notice that we have an xy point, so we can plug in x and y and find r. So we have almost all of our information we need except r, but we can plug that in because we have both x and y and h and k. Yeah, don't forget that is h and k. Okay, so let's plug that in and see what we can find. So I'm going to go ahead and just rewrite this equation. Oops. Yeah. Well, yeah, I'm gonna rewrite it. I don't wanna skip a step here. So we're just rewriting the equation of a circle, and let's plug in the values that we have, right? So that being 3 and -2 for h. So we've got x minus 3 squared and y minus a -2 quantity squared. And then we still need to know what r squared is. Okay, so we can plug in, this in a parenthesis, we can now plug in x and y. So x and y, yeah, being 1 and 5, so we've got 1 minus 3, that squared, plus, where are we at here? 5? 5, I'm going to go plus 2, right? We're subtracting a -2 or adding 2, and that's equal to r squared. Okay, so let's simplify this down. What is 1 minus 2? Or what is 1 minus 3? It's a -2 squared. What is 5 plus 2? That is 7. 20 squared equal to r squared. Okay, so -2 squared is a positive 4. 7 squared is a positive 49. And what is 4 plus 49? Let's go down just a little bit more. It is a positive 53. Good, thank you. Okay, so finally take the square root on both sides. So we've got a plus or minus square root of 53. Before we can continue, be thinking, can we break apart 53? Right? Well, let's start running through some numbers. It's not divisible by 2, so 2 doesn't work. Is it divisible by 3? It's not divisible by 3. 4? No. How do I know that? It's not divisible by 2. You can think the closest thing to, multiple of 4 would be 40, 44, 48, 52. So it's not that, and it's not 5. So there's no number. 53 is prime. Another thing, another way to tell if something is prime is if you have the square, like look at what the square root of 53 is. What is the square root of 53? Well, again, we're online now, so I wouldn't, you can use a calculator. It's approximately 7.28. So if you wanted to find any prime number that divides into it, right, you go up to 7, right? So that means you could check 2, 3, 5, and 7. If you check these, so 2 doesn't work, 3 doesn't work, 5, right? We've kind of thought about this, logically here. 5 doesn't work. And 7, doesn't work because 49 is the closest and you go up a little bit more. So if you check all these numbers, which you get by just taking the square root of the number, you know that it's prime. Any questions on that? It's kind of a neat thing. If you want to know if something's prime, take the square root and then check all the prime numbers leading up to that. And if none of those work, then it's prime. Okay, fun stuff. Okay, so 53 is prime, is what we've concluded. And so what that means is we have just the square root of 53, right? Again, we can't take a negative square root, or we don't have a negative distance. Okay, so what has all that led to? Well, it leads to us being able to fill in this equation, right? Because our question is, well, what is the equation of the circle? Is it copy? And then I think this is paste. Nope, this is paste. There we go. Yeah, so we can fill in the equation of the circle with what we know. And what we have found is that the center, which I guess is what we're given, is +3 and a -2 or a +2. I think Alex would probably mark you wrong if you wrote a minus a -2. I think they would be like, you should simplify it. And it is a 53. Now, I guess just so it's clear, right, it is the square root of 53, that squared, right? So again, I think Alex would mark you incorrect by having that. It's a +53, not the square root. I don't know why it's green. Uh-oh. Are there any questions on this problem here? Okay. We're gonna move on. Back. Huh. Okay. So that ends our discussion with circles so far. Now we want to introduce a new topic, which is midpoint. Okay, had a pin freak out there, but I think we are back in business. Okay, cool. If anyone has seen the lecture from last Thursday, I got really angry and I was hitting this digital pin or this digital pad because I couldn't get it to work. Okay, but we kept our temper, and now we are on to the fourth section of 9.1, which is the midpoint formula. So this is saying that if you wanted to find the midpoint on this line, what you'd have to do is add our x values together, divide those by 2. That puts you here with the x value, and then do the same thing with the y value, and you're at the midpoint of this line segment. I can't see this, but I think everyone else can, because no one can see what I have. Okay, sorry. So yeah, we're having midpoint formula given by this for that line segment. So we're gonna just practice it, right? Let's find the midpoint of this line segment down here, right? Well, what is the line segment? Well, it's given by -4, 6, and 8, 1. So to find the midpoint, I'm gonna define it by m. So, right, you can think of this as just equal to m, the midpoint. The midpoint is going to be equal to x1 plus x2 divided by 2. Y2 plus y1, let's be consistent, y1 plus y2. Again, it doesn't matter the order that you add them. So plugging this in, remember this is x and y. Let's call this x1, y1, x2, y2 to help us keep things straight. So x1 is going to be -4 plus 8. Divide that by 2. And that's a y1. It's going to be 6 plus 1 divided by 2. Okay, so let's add these together and simplify. So the midpoint, the x value is going to be, what is this, -4 plus 8 is 4 divided by 2. Here we have 7 divided by 2. The only one of these that can simplify down a little bit further is 4 halves, which is just 2, and we have 7 halves. Again, I would just keep it as a fraction. You could write 3.5 if you would like, but you do not have to. And there's your midpoint. Any questions on finding the midpoint? Okay.
Is that an H or?
Oh, no, it's y1.
Okay.
I'm gonna fix it. Yeah, it definitely looked like something. I can see why you see H. Thank you. Yeah. Okay. So yeah, so we've actually got a daily work problem that deals with this here, which was the first one. So it goes a little out of order, but we want to find the midpoint. I'll move it down to right there of this line segment, right? So we know that it's somewhere in here. Okay, so recall that your midpoint is given by x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Yeah.
Can you go back up just a
Oh,
little bit?
yeah. Is that pretty good? Or do you want to go a little bit further? Oh, you got muted again. Is that okay?
Yeah, just one moment.
Okay, yeah, you're good. Yeah, so again, it doesn't matter the order that you write your x1 and x2 because we're doing addition. The order isn't relevant there.
Okay. Yeah.
Yeah, so Alex includes a picture here, which I don't think it's very helpful at all. So I don't know why they did it. I guess so you can know if your answer is legitimate. Well, we'll see what I mean. Like we could look at the one we just did. Move this a little bit closer for me. Okay. So again, it would be good to label these. Let's just call this x1, y1, x2, and y2. All right, so substituting this into our midpoint formula, we've got 6 minus 4, or let's write it like this. We've got 6 plus a -4. We're dividing that by 2. Here, y1 is 8, so we've got 8 plus a -4, dividing that by 2. Right, so plugging that into our midpoint formula, we get here on the left, or the x coordinate, is 6 plus -4, or 6 minus 4 is 2, divided by 2. Here we've got 8 plus -4, or 8 minus 4, which is 4 divided by 2. So this reduces down a little bit more to 1 and 2. So our x and y coordinates for a midpoint for this line segment is 1 and 2. I guess Alex gives you the lines because, be thinking that this here is -4, this is -4, this is 6 and 8. So by just kind of labeling roughly where it is, right, does it make sense for our midpoint to be 1 up 2? Well, up 2, right? Our midpoint would be somewhere around here, right? So I guess they give you the graph. So if you get a midpoint, right, if you added something wrong and this was -1, well, that obviously wouldn't be right because it'd be saying like somewhere over here. So Alex is probably just giving you the graph to help you reassure that the midpoint you're finding makes sense. It's always good to look at it and make sure that you're on the right track, that you're not finding some midpoint that is like way over here. That'd be my best guess. Okay, so what we want to do now is we want to use our midpoint formula to help us solve one more problem with a circle, right? Given a little bit less information, but using the idea of a midpoint. So I'll move it down just to about right here. Okay, so I moved that up too far. Oh gosh. Okay, so the problem is saying, suppose that -2 and 3 and coordinate point 4, 1 are endpoints of a diameter of a circle. The question is, can we find the center of the circle? And furthermore, can we have the equation of the circle? So wow, that is a lot of information, right? Um, well, remember what the diameter of a circle is. We didn't define it up top, but the diameter of a circle is the radius times 2. So what it's saying here is if I had these 2 points of my circle, where's my shape here? And I wanted to draw a line, this would be my diameter. And the diameter of my circle is 2 times my radius. So each one of these is your radius. So your diameter, let's call it D. That's supposed to be one of those like squiggly lines, but it's not very good. There's a couple things I cannot draw, and this is one of them. Only this and like, you know, a lot of other animals, I have trouble drawing those. Okay, so this is D, which is equal to 2 times your radius. So hopefully you're looking at this and being like, well, we're given some pretty good stuff, right? That these 2 points are the end of your diameter. So be thinking that, well, what if this was -2, 3, and this was 4, 1? What could we do? Well, we can find the midpoint, right? Because it's right in the middle, right? And so finding this, our midpoint, is going to give us our center of our circle, and then we can work from there to find the whole equation of it. Okay, so yeah, what we need to do here is we need to find the midpoint. Midpoint starts with an M. Midpoint of -2, 3 and 4, 1, because we're looking for that center of the circle. Okay, so the midpoint is again given by x1 plus x2 divided by 2. You're just finding the average of these two, the middle point there, both x and y. So plugging this in, I need a little more room. What do we get? What do we get for our x coordinate if you're working along? While I figure out how to get all this written. Well, what do we got here? We got -2 plus 4 divided by 2. And we've got, oh, well, let's just label these to be consistent. So again, making this x1, y1, making this x2, y2. I've -2 plus 4, and then 3 plus 1, and that is divided by 2. So when we work this out, we find that this is +2 dividing by 2 is 1, right? This is a +2, divide that by 2, you get 1. Or you can divide each one of these separately, right? So -1 plus 2 is +1. All right, here we get 4 divided by 2 is going to be 2. So what we find is our midpoint that is 1, 2. This is our center of our circle. Right? So that is what we found. That this point right here is 1, 2. Now remember back, right? What is our equation of our circle? I'll move down just a little bit to about right here. Right? Well, our equation of our circle is given by x minus x is x minus h squared plus y minus k squared equal to r squared, right? And again, h and k is our center. So what we just found by taking the midpoint of the diameter is, okay, guess we're not switching colors right now. It's not wanting to do it. Okay, I'm just going to continue on. Right, this is hk. Right, so we found the center of our circle, which is the point hk. Okay, so we can plug that in. right, we can plug in our center because we found that. It is x minus 1, or positive 1. So plugging that in, we get x minus 1 quantity squared and 2, or y minus 2 quantity squared equal to r squared. Okay, so notice now we've got 3 missing variables, right? We have an x, a y, and an r. But we're given this, these 2 endpoints out here, right? Our 2 endpoints or diameters of our circle, right? So here's an x and a y. Here's an x and a y, right? It falls on our circle. So we can choose either one to plug in. Anyone have a preference for what they want to plug in? I think choosing 4, 1 would be good. There's no negative on there, and we're a positive bunch of people. So we're going to sub in either negative 2, 3, or 4, 1. And like I just said, I'm going to choose 4, 1. So plugging in 4, 1, we get 4 minus 1 quantity squared plus 1 minus 2 quantity squared equals r squared. Remember, we need the equation of a circle, so we're solving for r to figure out what that is. 4 minus 1 is 3. 1 minus 2 is negative 1 quantity squared. And we get r squared. Okay, so 3 squared is 9. Negative 1 squared is a positive 1, r squared. So r squared is going to equal 10. I'm going to try not to move it up or move it down too much, to about right there. Is that okay? Good. Okay. Now we take the square root on both sides. Again, taking the square root, you get a positive, a plus, and a minus. But we reject the minus, right? Because, yeah. Question? Okay. We reject the minus because we can have a negative distance there. So we just have the square root of 10. Again, be thinking, can you simplify the square root of 10? Oh, this is working again. Cool. No, because it's 2 and 5, right? These are both prime. So we just have the square root of 10. All right, so to write the equation of our circle, we need to plug everything in. So we plug in h, k, our center, and our radius. So the solution is going to be x minus 1 quantity squared plus y minus 2 quantity squared equal to the square root of 10, that squared. Now again, I think Alex would probably mark you wrong to leave it like that. So we have 10 is the radius squared, and we've got y minus 2 quantity squared. And that right there is your equation of the circle. Are there any questions on this problem? Okay, move it down just a little bit because our daily work problem is now the exact same type of problem. So if this, seemed okay, then that's good because we're doing the same thing for daily work number 5. Okay, that is a little too large and off of the screen for me, so I'll make it a little bit smaller. Okay, everyone okay with moving down to about right there? Okay, so here we're not given the prompts, right? We're not given A and B that tell us what to do. But I think it's still good to have that method. So again, we have an equation of a circle whose diameter has endpoints -6, 3 and point -4, -5, right? So again, you're looking at this circle here, right? And you've got these endpoints of -6, 3. Oh, probably make more sense to have that on the right side, right? So your diameter, -6, 3, and -4, -5. So you want to find the center point here, right? And that is the midpoint of this line segment, right? So to find the center, we're actually finding the midpoint between these 2 points. How do you spell between? Midpoint? I don't know. It's kind of redundant to say the midpoint between, because the midpoint is between. So the midpoint of -6, 3 and -4, -5. Yeah, really it's the midpoint of the line segment that includes these two, or the line segment between these two. But I hope everyone understands what I mean by I say midpoint of these 2 points. Okay, so let's do that. So the midpoint is going to be, again, x1 plus x2 divided by 2, and this is y1 plus y2 divided by 2. Right, so we're modeling it out of the problem above that had this prompt of finding the center first. So I'm going to go ahead and label this x1, x2, and this being y1, y2. Do we want to see this problem worked again, or do we feel okay with how it was worked above? What do we think? I'll let you guys be the judge. Do we want to see this problem worked?
Sure.
Okay. Okay.
Yeah.
I was making sure. I didn't want anyone to sit there and be like, I've done this before. Okay, so we plug it in to our midpoint formula. So we've got -6. Oh, wow. I've got some incorrect stuff on here. Let me fix this real quick. This is y1, this is y2, and that must be x2. So again, we're labeling our coordinates, x1, or our x coordinates and our y coordinates is what we have. So we get -6 plus a -4. Just plugging it into the formula here. Here you've got 3 plus a -5. So we got some negatives to work with here. Okay, I'm moving down just a little bit further to about right there. Okay, so working this down, -6 plus -4 is a -10, getting negative here. Here we got 3 plus a -5 is a -2. Now we simplify that a little bit further. These fractions both simplify down to a nice whole number or integer. -10 divided by 2 is a -5, and -2 divided by +2 is a -1. Okay, so we found the midpoint. Remember, our end goal is to find the equation of a circle. So we want to recall that the equation of the circle is given by x minus h squared plus y minus k quantity squared, and this is equal to h. This is equal to the radius squared. So again, finding the midpoint or finding the center, we just did right here, right? So this is our hk, which is why we found the midpoint of that. So now if we plug this in, just a little bit further, we have x minus a -5 quantity squared, and y minus a -1 quantity squared, and that's equal to r squared. So again, we've got some double negatives here, so we can rewrite this with addition. So x minus a -5 is x plus 5, y plus 1 when we do the same to that. Okay, so what we want to do is we want to use one of these points to plug in to find r squared, or to find r. So we substitute in either -6, 3, or -4, -5. Now, personally, I would choose this one because there's only one negative. I don't like working with negative numbers. So, the lesser of two evils, we'll choose -3 or -6, 3 to plug in. Again, you could choose the other one. You'll come up with the same radius. Okay, so substituting this in, we're going to get -6 plus 5, square that. You're going to get 3 plus 1, that squared, equal to r squared. Okay, -6 plus 5 is a -1. We still need to square that. 3 plus 1 is 4. got to square that, and it's equal to r squared. Okay, so following the order of operations, down just a little bit further to about right there. What do we get when we work this down? We get this is 1 plus 16 is equal to r squared. So we get 17 equal to r squared. Taking the square root of both sides and throwing out the negative distance there, we have that r is equal to square root of 17. Again, that doesn't solve our question, right, of what is the equation of the circle. Moving that over here. So our solution is going to be, again, I'm gonna use this line here because we've already plugged in our center. It's going to be x plus 5 quantity squared plus y plus 1 quantity squared, and it's going to be equal to r squared, which is the square root of 17 squared. Again, I think Alex will mark you wrong for that, so just simplify down to 17. And there is your equation of the circle. Any questions over this problem? Okay. Move it down just a little bit further. We're going to start our last section for this class, which is section 9.4. 9.4 is dealing with solving nonlinear systems. So recall back, I'm going to go down to about right there. So we're solving a nonlinear system of equations. So remember that we've dealt with linear systems, solving those linear systems, right? We would use addition and subtraction. So what this is saying, I'm going to go down a little bit further. About right there. Is that okay? Everyone over with that? Recall, this was a while back, but recall that a linear system, solving a linear system of equations looked something like 3x plus 2y is equal to 1, like negative 3x plus y is equal to 4 is equal to 3, right? So remember that, it looked something like this, or something like 2x plus y is equal to negative 4, and then we'd have like y is equal to 3x minus 1. Right. So remember that we had these types of problems before, right? And we would use addition, or we use the addition or elimination method or the substitution method to solve for both x and y, right? But these were linear equations, right? We had x and y, no exponents, square roots, or anything like that. So what 9.4 is going to throw at us is it's going to say, well, can we solve nonlinear systems? And we're going to do this using the substitution method. Now, you could use the elimination method for these types of problems, but they will be very awful. I will show you one towards the end here where I would use the elimination method, but for these, we're going to use the substitution method, and we'll see why we would do that. Just based on the people who are here, do we want to see using the substitution method for this problem here? For this just non-linear?
Yes.
You want to see that? Okay. So reviewing just this solving a linear system, let's look at this. So I'm going to move it down to right here, and let's solve it. Right. So let me make sure that we're going to get a nice number. Let's make this a negative 6. Because when we plug that in, yeah. Okay. So if we wanted to solve this, we're going to solve this system using substitution. So what that means is we want one of these variables by itself, right? So, and for example, we have y by itself. So notice that y is equal to 3x minus 1. So what we can do is go to the other equation, the one that we haven't dealt with, right? So this means that we would have 2x plus y is equal to negative 6. But now instead of a y, we can take y out, and what we're plugging in is everything that y equals. So in this case, y is going to be equal to this entire um, 3x minus 1, right? So plugging this whole thing, the whole quantity in for y. And then we solve, right? So we've got 2x plus 3x, that's going to be a 5x minus 1, combining just our like terms, that's equal to negative 6. So now adding 1 on both sides, this gives us a positive 5x equal to a negative 5. I'll go down just a little bit further. So that means that x must be equal to negative 1, right? We can divide by 5 on both sides. Remember what we're looking at here with a system of linear equations is we're looking at two lines, right? These are two linear linear functions, right? And they're intersecting at one point, right? That point being negative 1. But to find the y value, so use x is equal to negative 1, and we plug that in to either equation, right? That means either one of these equations. I'm going to choose to do y is equal to 3x minus 1. Why? Because it said equal to y. I think that it's a good choice to have. So when we plug in x is equal to negative 1, we'll have 3 times negative 1 minus 1, right? So this is going to give us a negative 3 minus 1, which is negative 4. Oh gosh, 4 and a y in one equation. Okay, so we find that our solution to this system of linear equations is negative 1 or negative 4. What we found is a point, negative 1, 4. If we were to graph this, we'd see that our lines intersect at that one point, this point in particular. Okay, are there any questions over reviewing this section? Keep in mind that this was going to be covered on Monday on our topics list, but I just tagged it onto this section because I wanted you to have Monday or this weekend to review all this material. So I realize this is a lot and we're shifting gears right away, but I just want you to be able to have all the information so tomorrow when I send out the review, you can work through this problem. So that is why we're doing that. Notice that it's 8:20, I think, or 8:19. So I'm going to go ahead and keep continuing. You're welcome to leave. This will be recorded so you can see it later. But just keep this in mind that this right here is basically what we're going to be doing, but we're not going to have linear equations. We'll have nonlinear ones. Okay, so let's take a look at the first example. Right, I'll show you a problem where you can use addition. I don't think you will. I think that you're going to be asked to solve problems that look like this. Okay, that sounds good. Have a good night. Um, so here, yeah, how would we solve this? Well, just like we did up above, notice that we had, I'll move up just a little bit, notice that we had one equation equal to y, right? So we had one variable already solved for, and we could just plug that into the other one. So notice that our top equation is just a regular linear equation. We have x minus 7y is equal to negative 25. So be thinking, or I'll ask this: what does this look like? What does this equation look like? It's something we just talked about. Anyone in the chat or anything have an idea? It's a circle, right? An equation of a circle. We have x squared and y squared equal to 25. So this is actually a circle centered at 0 with a radius of 5. So you can think about it graphically, and you could use Desmos, which I probably won't get too far into, but you could use something like this to help you graph it. But just be aware that you can think about it graphically. I'm not going to solve it by doing that, but you can do that. Okay, so to solve this, solve for one of these variables. So we want to solve for x. So that means we're going to add a 7y on both sides. Right? So that means our new equation is going to be x is equal to a negative 25 plus 7y. Right? We added positive 7y on both sides to get x by itself. Now, why did we do that? Well, now we can plug this in to this equation down here, right? We have a value of x, and we can substitute this in. So looking at the one we haven't dealt with, which is this one, we've got x squared plus y squared is equal to 25. So when we plug in x, we find that we no longer have x, right? Because notice that there's our x. We no longer have x, but this whole quantity. So what we're looking at is this quantity, y squared, everything else. So what we have is negative 25 plus 7y. And we need to now work this down because now we have y, but it's a quadratic, right? We've got y squared. So what is this going to simplify down to? We've got negative 25. This is some scratch work. Oops. And the scratch work is gonna help us here. So we're squaring this. So just so we know, the numbers are gonna be a little large, right? So when we square this, it's this quantity times that quantity. So negative 25 times negative 25. That's going to be, what, 625, I believe? 25 squared. Yep, positive 6.
What's that above the parentheses, the SW?
Scratch work. So that probably looks just even worse, but just scratch work. So really, I wanna simplify that down, but I'm doing it separately because I wouldn't want to do this in my head. It's kind of a lot of stuff to do. Okay, so I'm distributing this to each one. So 625. What else do we have here? Negative 25 plus 7. Or times 7 is going to give you a negative 175 y, and then the same thing, so minus 175 y. Again, that's taken the 7 to each one of these. So 7 times 7 is going to be a 49 with y times y, so y squared. Okay, so it is quite a bit, right? Let's simplify this down a little bit further. So we're adding the same thing twice, so that's going to be, what is that, 10, 1, that would be 14, 15, carry the 2. Is it 240? Is that right? Did I do that right in my head? 350. Could always check your work. All right, so adding 175 twice is 350y, so negative, plus 49y squared. So you're like, oh my goodness, there's so much going on here. Or there's like these numbers are quite large. So that's why it's good to work that out separately. Okay, so this is what that is equal to. So we got 625 minus 350y plus 49y squared plus y squared equal to 25, right? So just found that. What else do we have here? So we can we add the y squareds together. So that gives us a 625 minus 350y plus 50y squared, and that's equal to 625. Or excuse me, that's equal to 25. Okay, let's go down just a little bit further. Now, what we can do here is combine our like terms. The only like term we have is on the other side here, right? So we could subtract a 25, plus it's a quadratic, so we need it set equal to 0. So subtracting 25 on both sides, this is now 600 minus 350y.
Where did the plus 50y squared come from? I thought it was plus 49y
Oh,
squared.
yeah, so whenever we took this right here,
Uh-huh.
this is what the quantity negative 25 plus 7y squared was.
Oh,
We moved that down here, and then we still had a positive y squared on the outside.
oh, okay.
So yeah, and so combining those two together gave us this 50y squared. So again, yeah, I showed that work over here. Just I couldn't do that in my head. That would take a lot of brain power to do that. So we're down here. We subtract this on both sides. So now we have this quadratic. What I'm going to do is I'm going to rearrange it because I like my y squared or my x squared to be in front. So I'm going to rearrange it this way. So just moving everything around. Okay, now before I try factoring this or solving this quadratic, be thinking, is there a GCF that I can divide out? Is there a greatest common factor that divides both 50, 350, and 600? Well, there is 50. And we could think 5. 5 divides each one of these, and so does 10, right? So 50 divides all of these. So what we can do is go through here and divide by 50, and that'll make all the numbers a little bit smaller and easier to work with. So this becomes y squared. 350 divided by 50, think what is 35 divided by 5? That's 7. So we've got 70y. Yes, right? Because that would be, I think it would just be 7. It would just be 7. I did that before in one of the videos I uploaded. That's 7. And this right here, again, cross out your 0. That becomes, why am I having a brain fart here? 12. 12. Positive 12. Okay, so it started out really, really bad, right? This quadratic was pretty ugly. But we were able to divide out by our GCF. That is what happened here. So we divided by our GCF, which was 50. And we're down here. So now we need to solve this quadratic. So be thinking, what does this factor to? Well, we've got what adds to give us a negative 7, but multiply to give us a positive 12. That would be a negative 3 and it'd be a negative 3 and a negative 4. So these are our factors, y minus 3 quantity times y minus 4. All right, I'm going to go down a little bit further, just about right here, and just do the final step here to find our two y values, right? So our two y values being y is equal to 3 and y is equal to 4. Okay, so just like up above where we found our x value, right up above we found our x value, we need to plug it back in to find the other value. So in this case, we found our y. So now we're going to, I'm gonna draw a little line here. So we found this. So plug in y's to the top equation to find x. Now you can choose either one of these equations to plug it into. Personally, I would choose this one, right? Because it's not a squared term, so we won't have to worry about doing any factoring or anything. So really substituting it into x minus 7y is equal to negative 25 would be better. Right, the numbers are a little bit smaller to work with. I think that would be good. Okay, so let's do that. Let's let y equal to 3. And so that means we're choosing this one to plug it into. That means we're going to have x minus 7 times 3 equals negative 25. So multiplying this, we get minus 21, minus 25. So adding 25 on both sides. Right? Let me put that in here. 21, add 21. We get 4, negative 4. Let me rewrite that a little bit further over here, negative 4. Okay, so there's our one of our x values. Now we have to do the same thing for y is equal to 4. Right, so we've got x minus 7 times 4. Where are we at here? Equal to negative 25. So we've got x minus 28 equal to negative 25. So adding 28 to both sides. We've got y, or we've got x. Oh, yeah. We've got x equal to positive 3. So there are our two values. And so really what we have here is you can box your answers or report them as an ordered pair. So another way we can write our solution is 3, negative 4, and oh, goodness. Hold on. Write this. Our x value is negative 4, so it'd be negative 4, 3, kind of confusing. And this one right here is 3, 4, right? So either way you can report these answers. So that is the idea there, is you solve these by using substitution, but it's going to take a little more work to find that solution, right? We use our methods before. In this case, it was factoring. And when you factor, you can have up to 2 solutions. In this case, we did. So we substitute those back into one of our top equations. Again, I chose the non-quadratic one because working linear stuff is nicer. And then, you get 2 x values because you have 2 y values. Okay, now I've got 3 more examples. This one right here is a nonlinear example with a square root. We'll work this one. The daily work problem, the last one, is very similar to this one. And actually, this one came out to nicer numbers. So I think I'm going to not work the other daily work problem and include this as your daily work number 5. So, or this will be your last daily work problem, this one. I just think the numbers worked a little bit better. We can see later on that it's similar to that, but I've worked the daily work problem and we got some fractions, but I like this one. Okay, so let's continue on. This one right here is a square root. So notice that we've already solved for y, right? Y is equal to the square root of x, right? So what we can do, oops, is plug this in for our value, right? So we've got that y, so y, is equal to the square root of x. So using this other equation for a circle we have down here, we can plug this in, right? So y is equal to the square root of x. Well, instead of y, right, we now have that value that it's equal to. Right, again, this being our y. Gosh, that made it look worse. Right, that is equal to square root of x. So substituting this in, think of it, you're plugging that in for there. We're here, right? So notice now we only have x's, right? We've taken out our y and we've plugged in an x. So what's this going to do? Well, this is x squared. This right here, the square root squared is just x. So we've got x, and this is equal to 20. So now we're down to a quadratic. So this quadratic is going to give us up to 2 solutions. So we can subtract on both sides because again it's a quadratic. So we need to set that equal to 0. So I subtract 20 on both sides and factor. So what does this factor to? So be thinking, how can I break this apart? Well, it needs to add to be 1, multiply to give us negative 20. So pause for a second. Do you find it to be a positive? I was wrong. Do you plan on it being a positive 5 and a negative 4? Right? That is how that factors. So that means, moving on just a little bit further. Does that mean, or right, this implies that x using the zero product property gives us -5 and x is equal to 4. So the reason I included this one in particular is notice that we're going to exclude -5. Now, why are we going to exclude -5? Well, it's because we're looking at y is the square root of x, right? Remember that for a real solution, which is what we're looking for, this can't be negative. Or let me write it down here, right? We can't have a negative underneath the square root, right? So this has to be non-negative for a real solution, right? Because if we plugged in -5, we would have an imaginary solution. So we exclude this because it is out of the domain, is out of the domain of y is equal to square root of x. So it's nice, right? In this case in particular, our square root helped us get rid of one of our solutions we need to check. So now we only need to check one. So this means that we need to find, or let's say, let x be equal to 4, because that's what we found, right? This is one of our solutions, and plug it into either equation. Again, I would choose the one with smaller numbers. And the one with smaller numbers, I would say, would be the top one, right? Because the bottom one, you know, it's a circle, so you plug it in and square it and do all that good stuff. But let's just use this one here. So x or y is equal to 4, right? So we're looking at this right here, so plugging that in. So y is equal to 2. So we find here that we have one solution, right, where these two, the circle and the square root function intersect, and it's at 2, 4, or excuse me, 4, 2. So you can also write it as an ordered pair. So this only has one solution. In this case, it's 4, 2. Any questions on this one? Again, the daily work problem would be next. Move it down just a little bit. Notice it's this right here, but it's exactly how we did the last problem. Not this one, but the one before it. So I'm not going to work on this one just for sake of time, but it's very similar. And actually, the one up above has nicer numbers. This one, you end with some fractions, which is fine. Like it's just, you know. Okay, so I'm gonna go ahead and talk about the very last couple things here. Right, we've been using substitution for this. Why is it okay if I move down a little bit? And delete this out of here. Okay, so the very last type of problem, I don't think you'll see this. I really don't. I don't think you'll see it on the test or the final, but I want you to be aware, like, you could do this with the addition method, just like you were solving a regular system. But just, you know, right, with the system of linear equations, whenever you'd add them straight down, you could get rid of a term, right? But notice here, you can't do that. It would be really, really ugly. So what I'm saying here, right, is if I multiplied this by a -x, this would give what, -x squared, oh gosh, plus 7xy is equal to positive 25x, right? You can do this using the elimination method, but it's not going to help you too much, because when you add straight down, right, you get rid of your x squared term, but now you have 7xy plus y squared plus 25. And it's like, this right here is a hassle to solve, right? I mean, it would not be anything I would like to do. You would have to do elimination again. So, you know, notice we didn't use elimination for these types of problems. So don't use elimination. A problem that you would want to use elimination on would be a problem where you've got matching powers and terms. So for example, here, I would use the elimination method. Now again, I don't think you'll see this,
Was what you wrote down up there a second ago, is that,
Oh yeah, sorry. Right here?
yeah.
Yeah.
Okay.
So really,
Right.
like, you don't have to write it down. I just want to show you why we didn't use elimination method. So that's recalling back to like a previous section. I wouldn't use elimination method here. It's rough and gross. Like for this example here, notice that we set it equal to x, right? And then we plugged this in. So we didn't use this method, and I wouldn't use the elimination method. Again, I don't think you'll see this type of problem down here, example 4. I don't think you'll see this in your ALEKS work. But I just want to show you like what you'd have to do to solve one of these. I'm not going to go through the whole solution because you're going to find out like, wow, that is a lot of work. But again, I don't think you'll see this. So I don't know for sure. I'm not going to put it on the test, but just so you're aware. So this won't be on the test. At least I'm gonna confidently say it won't be on the test. It'll be on the final, but it won't be on the test. Okay, so yeah, how would we go about solving this using the elimination method? Well, remember you want these to be the same but opposite, right? To use the elimination method. So for example, let's go ahead and do this one, right? Let's say we want to eliminate the x's. Well, you multiply by 2. So that means we now have x squared. Let me make this a different color. Let's make this green. Make this orange. Oh, wow. Okay. -2. All right. So we got just the top equation hasn't changed, right? So just moving everything down here. Bottom equation now becomes -2x squared minus 4y squared, and that's equal to -44, right? So just using the same idea of elimination, we add straight down. This is 0. This is a y, so not a 4. So this is -3y squared, and that is equal to 44 minus 17, or -44 plus 17, which is a -27. So once we've done that, divide by 3 on both sides. Let me write that. Right, so division by 3 is going to give you a +9, right? -27 divided by -3. So that means when you square root both sides here, you're going to have plus or minus 3. Okay, so once you do that, now you have to plug that back in up above. So notice both of these are equations of a circle. So really, you're going to have 2 more solutions, right? So you need to plug in y is equal to 3 and y is equal to -3 to either one of these. Which one would I choose? I would choose the top one. So again, either equation would work. I'm only choosing this one because there's no 2 multiplying the y squared. And plug these in and solve, right? And that is how you would find your x values. Again, I don't think you'll see one of these problems. I messaged one of my friends who taught this class last semester, and I asked her if these type of problems showed up, and she wasn't sure. She couldn't remember. But for your ALEKS problem, again, refer back to the one we worked up above using substitution. Okay, so that's it. I'm not going to solve the rest of that. You definitely can, plug it in, see what you can get. Are there any questions? So that ends the material for intermediate algebra. I'm going to finish getting the review put together, and I'll send it out tomorrow. And that way you'll know what problems to study and what would be on the test. So if there are no more questions, we can meet up on Monday for a review over the material. So any last questions before I stop the meeting?